In this section, our goal is to be able to use angles, arcs, chords, tangents, secants to investigate, verify, and apply properties of circles. We want to be able to find angle and arc measures created by central angles, inscribed angles, and angles in the interior or exterior of a circle. Let's start by talking about what is a central angle. Well, that's obviously a kind of angle, but the vertex is what makes it a central angle. The vertex is the center of the circle. Central vertex is the center. For example, I could draw a central angle by connecting radii from P to A and P to B. So I have central angle APB because P is the center of the circle. So angle APB is a central angle. This angle looks like it's about 80 degrees. So let's go ahead and put the measure there so that we can write that the measure of angle APB equals 80 degrees, just so that we remember how we write the measure of an angle. And arc is just part of a circle. And sometimes we call that an intercepted arc when it's being made by an angle. For example, the sides of angle P hit the circle at point A and hit the circle at point B. So the arc being intercepted is this minor arc right here, arc AB. Why did I call this one a minor arc? Because a minor arc, think as compared to major. Minor means less, major means more. Minor, small, major, big. Minor is less than halfway around the circle. So that's why from A to B, that arc is only a minor arc, because going halfway around the circle would be at least that much. The way we write an arc is with the two letters of its endpoint, if it's a minor arc, and then a little arc hat. So instead of a straight segment hat, a little curved arc hat. So arc AB is a minor arc, and the measure of arc AB, notice how we use M here for measure like we used for angle, also equals 80 degrees, because whatever the central angle is, its intercepted arc will be the same amount of degrees. Major arc, major, think big. So that's going to be more than halfway around the circle. Now, let's say that we want to go all this way around the circle. We want to go from A to B, but we want to go the long way. If we want to go the long way from A to B to show that major arc, we can't just say AB is the arc, because that would mean the minor arc. So we have to give a point that is somewhere on the path going the long way around the circle. So the way we name that arc is arc ACB. Arc ACB is major. So usually when you see three letters, it's because we're going to take a longer way around the circle. The measure of arc ACB, well, now we have to think about what we know about circles. To go all the way around the entire circle, how many degrees is that? 360 degrees to go all the way around. So if we want the green part, the major arc, we don't want the part that's 80 degrees. So when we talk about what we don't want, we want to take it away. So we're going to subtract what we have and don't want from the entire way around the circle. 280 degrees. Notice that's more than halfway. How much is exactly halfway around the circle? Just halfway? 180 degrees, because that's half of 360 degrees. And that's a semicircle. Semi means half. Circle, so that's exactly halfway around the circle. Now I don't have a picture here to show halfway, so I'm going to take this radius and extend it to create a diameter. I'm going to call this point D. So halfway around the circle, I kind of need to know endpoints of a diameter. So let's write that we need that. Endpoints are of a diameter of the circle. So I drew a diameter of the circle, and then I can say arc A, and it doesn't matter if I use a letter because going from A to D is exactly halfway either way. So I could say arc ABD, or I could just say arc AD. So arc ABD is a semicircle, and the measure of arc ABD is 180 degrees because that's exactly halfway around the circle. Now, what if I wanted to know how much arc DB measures? How much would that have to be? Well, from A to D, all of that is a semicircle, so that's 180. What's left over for this little guy right here? Did you think of it? That's right, 100 degrees. Why? Because 100 plus 80 makes 180. And that's the arc addition postulate, is arcs next to each other add to make a larger or a longer arc, such as arc DB and arc AB. So we can say, for example, the measure of arc DB plus the measure of arc BA or AB equals the measure from D all the way to A. Or using numbers, the 100 degrees plus the 80 degrees makes up the semicircle 180 degrees. Let's do some examples. Given information, we should label our picture with this. Segment AB is a diameter of circle P. That's important to know. From A to B, that's a diameter. So right away, that tells us that all of this is 180 degrees. Also, the other half, all of this, 180 degrees. AD is congruent to BE, arc AD is congruent to arc BE. So arc AD, this one right here, I'll put a little congruent slash in there, same as BE. And arc BF is congruent to arc DE. The measure of arc DE is 80 degrees. So this one is 80 degrees. Notice how I like to put the arc measures outside of the circle. Now before we continue, if it says that these two are congruent and this is 80 degrees, I might as well also right away mark that this one is also 80 degrees. That's going to be helpful. Let's continue to read the directions. Determine whether the arc is a minor arc, a major arc, or a semicircle of circle P, then give its measure. So we have to do two things. If we have to give a measure, I'd like to fill out as much as I possibly can in the picture before I go to the given arcs. So let's continue by figuring out what's left over. If this is 80 degrees and all that way is 180, what's left over for this little piece? Well, we did something like that earlier, 100 degrees. If these two are congruent, let's take away the 80 from 180. So 180 minus 80, again, that's 100. But then we have to split it up between these two that say they're congruent. So 100 divided by 2 gives us 50. So each of these little arcs is 50 degrees. Again, notice how I like to put arc measures outside of the circle. Arc BE. Arc BE, this arc right here says 50 degrees. Well, I was supposed to tell what kind it is. Notice that it's less than halfway around the circle, so it's a minor arc, and the measure is 50 degrees. Two things we have to give. Arc BAE. Arc B, A, E. Now, how did I know to go that way instead of B to A and then to E? Well, because I'd be backtracking. So from B, I have to go to A before I get to E. Notice that's the entire circle except for one little part, that 50 degrees. So that's more than halfway around the circle, major arc. And if it's everything, that's everything, but 50 degrees, I subtract from 360. So that's 310 degrees. FA, arc FA, from F to A. This arc right here already says 100 degrees. Done. Oh, but what kind of arc is it? Minor arc, because it's only 100 degrees, less than halfway around the circle. Arc ADB. Well, arc ADB, that's exactly halfway around the circle, so that's semicircle, and halfway is 180 degrees, as it says in the picture. Arc AE, from A to E. Now that's going to be putting two arcs together. To go from A to E puts the 50 with the 80. So we're going to have to combine those. Oh, and it's less than halfway around the circle. So combine the 50 and the 80, 130 degrees. And notice that's less than 180, so that verifies that we thought it was a minor arc. FDB. Now I gave this arc and this arc because it matters the order of the letters. FDB is different from DFB. Let's see the difference. FDB, arc F, D, and then B. So going from F all the way to D and then ending at B. So that's everything but this little minor arc. So that's a large way around the circle. And if it's everything but the 80, 360 minus 80. Oops, fix that. 280 degrees. DFB. Let's look at where that is. D and then F and then B. So from starting at D, going to F and then B. So that time it's a 50 put together with a 180. So 50 plus 180. Now I know I'm adding 180, so that's going to be a major arc too, because it's more than 180 to give us 230 degrees. Get it? So let's add one more thing in this, which is the relationship to the central angles. The central angle is exactly the same as the arc. So if this arc measures as 80 degrees, this angle measures as 80 degrees. If this arc measures as 50 degrees, this angle measures as 50 degrees. Same thing here, and here, and here. Arc measures, angle measures. If it's a central angle, vertex in the center, they're going to be the same.